All right, so over the past weekend, we took a little trip Saturday, and I picked up the machine I had wanted to pick up to make my collection line. So that's its predecessor, the Wheeler, and then the next Wheeler. But this is a 1870s Howe sewing machine. So I wanted to get a collection of all the founders of the sewing machine. So this thing is actually really incredible. It's really clean for how old it is. It works, and this is it running. It's a shuttle machine. So we'll open her up and check out how it's working. So it's a cam system, a tracked, let's say a tracked cam system. So there's the cam for your shuttle, and there's the cam for your arm, and then there's another lobe style cam for the feed dog, and another lobe style cam to activate the feed dog. So this is making the feed dog climb, and this cam is making the feed dog raise up and down. These tracked cams are doing the motion for your shuttle. So your shuttle, oop, got it against the wall there. There we go. So it's kind of a clunky machine. It's really fun to run because it's got this little dead spot in the cam right there. You see that flat? And that's the needle bar holding down as the shuttle has enough time to take up the string and get it around it, and then it starts moving. So it's a really cool machine to run, and it runs very beautifully. And it's got a certain sound and a certain feel to it when it's running. On these tracks, I think I'm going to put a heavier weight oil than sewing machine oil. I think I'm going to get a little separate can of gear oil and keep those a little more padding. But other than that, I do have a part I have to repair on it, which is this, the thread tension, the upper thread tension. The wheel is just really incredibly old, and I'm going to replace all these little felts in here. You have felts. Oh, that might be gone forever. All right, that's our wheel, and it's just starting to like delaminate. It's just coming apart. It's our cloth. So I'm just going to remake this. This is kind of like a soldered, like braze soldered, two thin sheets. I'm just going to make this in the machine shop out of solid. The Wheeler and Wilson one is a solid, so I'm going to kind of follow what they did. I'm just going to make a nice solid piece, and then just kind of mimic what they had going on, but do my own little touches. So wish me luck on this. We'll kind of go through it, and hopefully it'll work. Okay, so we got everything off of here. Measured the pin that it rides on is a 1/4 inch, and then we have the OD of the wheel we'll have to cut, and the wheel came apart. So there's a center to it, and then these were brazed on, these outer rings, but this outer ring's got a split, and it was cobbled together kind of with a little piece of plastic. And so what was happening with me when I was sewing with this thing or using it is that little split was putting a nick in the thread, and that little nick would go down and around. It would either catch somewhere in the workings, but it would generally catch down at the needle and cause the thread to fray out and pile up at the needle. You know, parts of the thread were going through the needle, and then the part was the wad that wasn't going, it broke off, is getting bigger and bigger, and you just jamming the works up. So we're going to make a nice new little wheel that doesn't fray our thread and perform. So all I'm going to do, which another thing, all these machines I'm working on, these were all made pre the international standards, you know, pre-Joe Block. And it's really fun because you measure each one of these parts, and all these parts are really bang on. They're like, you know, if you measure a 1/4 inch, it's a 1/4 inch part. So all their standard sizes were really there, and it was these are really nice to work on. It's not any crappy numbers out there. So there's a 1/4 inch bore, so I'm just gonna drill a 1/4 inch hole in that. I'm gonna put a 1/4 inch screw in this and hold it in the lathe, then bolt the plate to it, and that'll be supported enough to do my outer work, turn the OD, and I ground a cutter in the shape of a tiny little V just to touch off on the outside, and then I'll polish it up, reinstall it, and see if it's going to work for us. Alright, so we went out to the mill here. I switched out the vise and I drilled a little hole through that square, and then just since I'm doing one, I might as well do another one just in case I mess up. We've got our lathe, which is only 15 years newer, give or take a few, than the machine we're fixing currently. So we're keeping with the theme here of super old. And then all we're going to do is just thread this screw on here and pinch this plate to that backer, and that'll hold it parallel and true. And that drilled holes is central as it's going to get with this. And then we're going to cut the size, and then we're just going to cut a tiny little V-notch, microscopic V-notch to hold the thread, because that thread is grabbing just like a V-belt would in a pulley or sheave. So we're going to give this a try, and we'll see how it works. Okay, so we're back and about to assemble. This was the part that I remanufactured. I hope it works. I got a tiny little groove cut in there, probably about 40 thousandths deep. And the original, it does have, it's engineered just a tad bit better than mine because it goes in that inset, so it gives it just a little bit bigger of a bearing. But it's lasted this long, and I think mine's going to do just fine. So I'm going to put all my components in there. We cut out new felt pads. My felt pads, I always soak these in oil. I had a big issue with tension on a machine, and it seems when I soak these in oil, it alleviates that issue. So it's all going to be put back together with the new tension wheel, and we'll see if it works. Okay, so we got it, and it actually works perfectly. It is your thread, dresser, straightener, and just so it works just as it should. No more frayed thread. It's ready to run.